We know that any number that can be plotted on the number line is a real number. Consider root 2. This is a real number which is irrational and it approximately equals this value. It's non-terminating and non-recurring. It's easy to plot a number like 1 or 1.5 or 7.35 since they terminate. But how do we plot this real number? It's simple. We just use a different technique. Let this be a part of the number line. We have 0, 1 and 2 plotted on it. We know that this distance is 1 unit. Now let's draw a 1 unit length perpendicular at this point like this. This distance is the same as this distance. Both equal 1 unit. If we draw a segment like this, we get a right angle triangle. By the Pythagoras theorem, the hypotenuse squared will equal this squared plus this squared. Since both are 1 unit long, the hypotenuse squared will equal 1 squared plus 1 squared, which equals 2. Since the hypotenuse squared equals 2, the hypotenuse will equal root 2. This is the length we wanted, root 2. Once this is done, we can just keep the vertex of the compass at this point and cut an arc which cuts the number line. This distance will equal this distance as both are radii of the same circle with this center. So this distance will equal root 2. That's how we plot root 2. We do not measure the length and plot it. We form a triangle in such a way that we get root 2 as the hypotenuse. In a similar way, we plot root 3, root 5 and so on. To see these constructions in detail, please watch our videos on plotting irrational numbers on a number line. Now here's another interesting question. How can we plot a real number like square root of 3.8? We cannot form a right triangle with root 3.8 as the hypotenuse. There's another technique which we will look at in the second part of the video.